This is the second video in a two-video series on the car wash problem from Thinking with Mathematical Models. In the first video we looked at the getting ready portion, and now we will take the questions in the book, questions A through E. So now we move on to the problem itself, problem 2.2, and we start out with a new car wash called the Squeaky Clean Car Wash. Their information is given in a table of XY values, in this case actually a T and C values, but they are the same as an XY table of values. So the first thing we usually want to do is we want to look at the change in the independent variable and the dependent variable, and we notice in this table that the charge increases by $5 at every interval here. We also notice, so I'm just going to put a +5 right there. We also notice that the time increases in our table by 5 minutes each time. That's an important piece of information. That helps us answer the first question, how you know this relationship is linear. We know it's linear by whether it has a constant rate of change or not. And this one does have a constant rate of change. Every time the x value, or the time, increases by 5, the y value also increases by $5. Now we could also graph this and look at it. We'll know it's linear if the graph of this equation makes a straight line. Students are able to explain that in either way on this problem. Question number 2, what are the slope and y-intercept of the line? Well, we find the slope by what we call the change in y over the change in x, and we already determined that the y change was 5, a positive 5, and the x change was also a positive 5. So that simplifies to a 1-to-1 ratio, or a slope of 1. So next we look for the y-intercept, and the y-intercept is found on a table of values where the x value is 0. Now in our table, x being 0 is suspiciously missing from our table. So we have to find what it would be if it was there. So we kind of work backwards to do that. So I will add a 0 right here on the table where it would be if I went backwards one step. If I went 0 plus 5, I would get to 5, and if I go backwards 5, I'm subtracting 5. So likewise, I will do the same thing with the y value. So from 8 to 13, I go adding 5, and from 8 backwards then I would subtract 5. So 8 minus 5 is 3. That gives us a y-intercept value of 3. We can always find that on our table where the x is 0. Now once we have those two pieces of information, we can write an equation relating the charge c to time t in minutes. Now remember that an equation is in the form of y equals mx plus b, where m stands for the slope and b stands for the y-intercept. Now in this case, the variables are going to change. I'm going to use c for my dependent variable instead of y, so it would say c, or charge, equals, and the slope being 1, I would just put a 1 times the x, but the x value will be t because that's the independent variable, and then I add b, the y-intercept, which is 3. So our equation is c equals 1t plus 3, or students could simply write c equals t plus 3, as we don't need the 1 in front of the t necessarily. Next we'll look at Euclid's car wash. Their charges are presented in a graph instead of a table. Students are asked to come up with an equation for how Euclid charges customers for their car washes. So we still need those two vital pieces of information, the slope and the y-intercept. So from this graph, it's easy to tell the y-intercept. It's where our graph crosses the y-axis and x is 0. So our y-intercept will be 4. So I'm going to write up here b equals 4. The next thing we need to find is the slope. And if you remember, slope is the change in y over the change in x. Another way to say that is the rise over the run. And we use that when we're finding a slope from a graph. So I'm going to grab any 2 points on my graph, this one right here for example, and this one right here, and I do what I call I make what I call a slope staircase. Looks like this. And that staircase will have a constant rate all the way across my line. So then what I do is I find my rise. This staircase happens to rise 1. If for every run of 2. It does that for every step. So I put a 1 over a 2 as my slope. My slope is a fraction or a ratio of 1 to 2, rise to run. And putting those two things together, I can write an equation in y equals mx plus b form. But again, I'm going to use c for charge and t for time. So the charge here is 1/2 times t plus $4. In other words, 50 cents a minute plus a $4 starting cost to use their car wash. Part C of our problem brings a new car wash called Super Clean Car Wash, and in this situation we have 2 receipts from using the car wash. The question asks us to find XY coordinates based on the data, and they are in t, c, where t is the x and c is the y, as we've been discussing. So I need to find time and cost from each receipt. On the first receipt dated 3/14/05, I notice that there's a time expended of 10 minutes. So that's my t value, or my x coordinate. And I know that the charge was $7. That becomes my y coordinate. So putting them together, I have a 10,7 xy coordinate or ordered pair that I could use for the situation. Now in the second receipt we do the same thing, and here we have a time of 20 minutes and a charge of $12. So my xy coordinate, or my tc coordinate, would be a 2012. Now one of the skills involved in this situation is finding the slope and y-intercept from 2 points instead of from a table or graph. At this level, a lot of students will just make an xy table of values. So it would look like t and c for the x and y, and they're just going to put the data in that they have. So there would be a 10,7 ordered pair and a 2012 ordered pair. Now from there they can find the change in x and the change in y. So the cost, or the y value, would increase by 5 as the x, or the t, increases by 10. So if I put my change in y over my change in x, that would be a 5/10, which can be simplified to 1/2, and that's what we prefer. So the slope is 1/2. Next we need to find the y-intercept, and again that is where x is 0. So if I added a 0 to my table right here, then I would be going from 0 to 10 forwards or 10 to 0 backwards, and I would do the same thing for my y value, or my cost. And since that went up by 5, going backwards I'd be going down by 5. 7 minus 5 would be 2. So there is my y-intercept at 2. Putting these together, I can write an equation for this line where c equals 1/2 t plus 2. Now there's a different way to find the slope between 2 points. And if I was to write again the ordered pair 10,7 and 20,12 down here for each receipt, there's a formula we like to use: y2 minus y1 over x2 minus x1. And this is a way to find the slope between 2 points. So what I like to do then, we do the same thing with the x values, x2, and it's important that these go in the right order. 20 minus x1, which is 10, and you'll notice that we're going to get the same value we got by making a table, which would be 5/10, or 1/2. Parts D and E get a little bit more complicated, a little bit more into algebra. And D, a lot of students will graph. They will start out at a point 4,3, and they will graph a line with a slope of -3 from there, so we would drop down 3 and over 1. I'm not going to take the time to do that on this video, but that is one way to find that, where that line goes. And if you find where that line goes, you can find the y-intercept from your graph. Another way to do it gets a little bit more involved with equations. So what I would do is I would start out with y equals mx plus b as my basis for my equation, and I would put in the things that I know. So I know it has a slope of -3, and I know it has many points on the line, but one of them is 4, 3. Now the 4 is the x value and the 3 is the y value, so I will substitute those in the equation where they go. So instead of x I'll put 4, and instead of y I'll put 3. Now that leaves me with only one part of my equation that's unknown, which is b, the y-intercept, which is actually pretty nice because now I can solve for b. So negative 3 times positive 4 gives me a value of negative 12, plus b on the right side of my equation equals 3 on the left side. To get b by itself, I want to add 12 to both sides, and I get a b value that's worth 15. And since I know that is my y-intercept and I know my slope is negative 3, I can write an equation that looks like y equals negative 3x plus 15. Now a little more practice with letter E, writing equation for a line between 2 points. So a lot of students will make an XY table of values to get started with, and they will put the data they have. They have one point at 4, 5, another point at 6, 9, and we use that table to find the slope, which is the change in y. So that's a positive 4, that goes on top of my ratio or my fraction, and the change in x is a positive 2. So as y goes up by 4, x goes up by 2. So that would be a 2 there on the bottom of my fraction. So that simplifies to 2. So there's my slope. Next I need to find my y-intercept. And you remember on a table of values, that's where x is 0. So I don't have 0 on my table, so I need to work backwards. I'm going to expand my table and put a 2 for x and a 0 for x. So I'm going backwards by 2 each time until I get 0. So if I continue to go backwards for y, instead of adding 4, I'll subtract 4. So 5 minus 4 is 1. And then 1 minus 4 is negative 3. So there is my y-intercept. Putting those together, I can write an equation that says y equals 2 for my slope times x minus 3 for my negative 3y intercept. Well, I hope this video has been helpful to you working with the car wash problems and thinking with mathematical models. Feel free to email me or ask further questions at this email address.